Today we are going to look at evaluation of integrals of complex functions using residue theorem. From our last lesson, we have introduced to us what do we mean by residue theorem, and I will quickly try to summarize it here, that if f of z is analytic inside and on a closed curve C, except at the singularities A, B, C inside C, which have residues A1, B1, C1, then the residue theorem states that integral of f of z, integral of f of z dz is equal to 2 pi r into sum of the residues So it is based on this that we are going to discuss today. So let's quickly go to a given example. This question says that you should calculate the residues at all the poles of f of z equals minus 3z divided by z squared minus 1 into z plus 2 raised to power 2, and use your result to evaluate integral of 3z minus 3z divided by z squared minus 1 into z plus 2 raised to power 2 dz, where C is the circle enclosing modulus of z is equal to 1. Solution. So like the question says, we must first of all calculate the residues of the poles that we have here, and from here we set z squared minus 1 into z plus 2 raised to power 2, we set it to be equal to 0. So from here, when you solve, you have your z is equal to 1, z is equal to plus or minus 1, z plus or minus 1, and these are poles of order 1. Then z is equal to minus 2 is a pole of order 2. I hope you will understand how we got my z is equal to minus 2 and z is equal to plus or minus 1. This is a quadratic, this is factors, and two factors are multiplying themselves together to give a 0, meaning that each one of them will be equal to 0. So you can now solve separately. So you solve separately, z squared minus 1 is equal to 0. So z is equal to z squared is equal to 1. Z is equal to 1. So z will be equal to plus or minus root of 1, which is plus or minus 1. So that's how we got that. Okay. So After getting the poles and the order of the poles, we now try to calculate the residue. So we say at Z is equal to 1. So sorry, this is 1. So plus or minus, let me write it very well. Plus or minus 1. So these are plus or minus. So as Z is equal to 1, the residue is, now I have the residue to be A1 would be limit as Z goes to 1 of, no, it's a pole of order 1. No, let's first of all start as a pole of order 1. So we now have Z minus 1, then f of Z. F of Z is 3Z into, so that's 3Z minus 3Z divided by Z squared plus 1. Z squared, so that will now be Z plus 1, Z minus 1, then into Z plus 2 squared, Z plus 2, everything is to power 2 squared. So that's a Z. So with this one, this and this will go. So you are left with the limit as Z goes to 1 of minus 3Z over Z plus 1, then into Z plus 2, everything squared. And this will be, by the time you substitute Z is equal to 1 there, so we have minus 3 into 1 plus 1, then into 1 plus 2, everything squared. And upon simplification, we have minus 3 over 3 squared multiplied by 2. So 3 squared multiplied by 2, and that will now be equal to minus 1 over 6. So minus 1 over 6. So that is the residue. Again, we find the residue at Z is equal to minus 1. So the residue would be A2 would be limit as Z goes to minus 1, then into Z plus 1, then minus 3Z divided by Z plus 1, Z minus 1, then Z plus 2, everything squared. So from there we have some cancellations. This and this will cancel, so we are left with limit as Z goes to minus 1, then into minus 3Z divided by Z minus 1 into Z plus 2, everything squared. And this will be equal to, so you have this one. When substituting the value of the limit, you have minus 3 into minus 1 divided by minus 1 minus 1, then into minus 1 plus 2, everything squared. And this will be 3 divided by minus 2 into 1 squared, and the result will be minus 3 over 2. So that is the residue when Z is equal to minus 1. So now let's try to calculate the residue when Z is equal to minus 2. So at Z is equal to minus 2, now this is a pole of order 2. A pole of order 2. A pole of order 2. So the residue will now be we have the residue to be A3 will now be equal to limit. Limit as your Z goes to minus 2 into 1 over 2 minus 1 factorial. If you remember that formula, you can check my former lecture or former note on that. 2 minus 1 divided by dz 2 minus 1 then into z plus 2 raised to power 2 f of z. F of z will be minus 3z divided by z squared minus 1 into z plus 2 everything squared. So, and this one will cancel, so you have this one and this one cancelling. So you are left with this limit z goes to 2, then this is 1 factorial, then into d dz. So we now have minus 3z divided by z squared minus 1. So that is what you have there. So yes, that's what you have. So by the time you do your differentiation using quotient rule, we have limit as z goes to minus 2, then we have z squared, we have z squared minus 1, then into minus 3, then minus that's minus 3. So you have 3z squared, so plus 6z, that's be plus 6z plus 6z. You know, how do we get that? You know, it's minus minus 3z into 2z. So this one to that will not be z squared. So you have your z squared here. Then everything divided by z squared minus 1, everything squared. So, and this will give me limit as z goes to minus 2 into 3z squared plus 3 divided by z squared minus 1 is to power 2. So that will be the result. By the time you substitute your minus 2, you have that is 3 into minus 2 squared plus 3 divided by 2 squared minus 1, everything squared, which is this will be 4 times 3, that will be 12 plus 3, that will be 15, then divided by this will be 4 minus 1, that is 3 squared, that will be 9. So you have 15 over 9. So that is the residue. So that's the question now says that you should find the integral of this one, where C is the circle enclosing Z, modulus of Z is equal to 1. The implication of this one is that this particular pole, which is of order 2 here, is not enclosed in modulus of Z is equal to 1. The implication, this means that minus 1 is less than Z less than or equal to 1. So that is what we have. So any value that is not between minus 1 and 1 will not be counted in that pole. So, and you know that the residue theorem says that integral of f of z dz equals 2 pi I multiplied by sum of the residues enclosed by C. Enclosed by C. Enclosed by C. So in this case, our C is only enclosing 1 and minus 1. Therefore, we have that integral of that function. Integral of that function will now be equal to minus 3 z divided by z squared minus 1 into z plus 2 raised to power 2 dz all into C will now be equal to 2 pi r into sum of the residues. So, and the sum of the residues will now be minus 1 over 6. Minus 1 over 6. Then minus 3 over 2. Minus 3 over 2. And upon simplification, we have this one to be minus 10 over 3 pi r. So this is the result of that. Mind you, we have this one and we have this one to be those residues that we are going to add. So that is what we are going to learn now. And I want to give exercises as usual, and I'll give you the solution to that exercises. So I'll say calculate the residue of all the poles. Calculate the residue of all the poles of the following functions. And hence evaluate the integrals. So 1. So the first one is integral of C z raised to power 6 plus 3 z raised to power 5 plus z cube plus 2 divided by z plus 2 raised to power 4 dz, where C is any simple closed curve enclosing z is equal to minus 2. So I want to say answer here. Answer. The integral. Answer will be minus 78 pi r. That's answer. Minus 78 pi. Minus 78 pi r. The second one. We also have this integral of 2z squared minus 3 divided by z squared plus 1 into z plus 2 everything squared dz, where C is the circle. Where C is the circle. C is the circle. Z, modulus of Z is equal to 1. And the answer to this one is, the answer to this one is 8 over 5 by R. Let me give another one so that it will make 3. So the third one, 3. Third one. We have integral of 3z minus 2 divided by z minus 1 everything squared, z plus 1, then z minus 4, minus 4 2z, where C is the circle containing Z is equal to plus or minus 1. So the answer to this one, is the answer is minus 4 pi 4 over 9 pi r. Thank you. So I hope you are enjoying the class. Next time we'll meet.